Hi guys, hope you're doing fine. Let us try to understand um, list comprehensions and doing the same thing using a for loop and how it differs in terms of performance. All right. So I have a function which does uh, append numbers to this particular list, and we have about 10 million elements to be inserted into this particular list. So let us try to find out how long it takes to do this task. So I have this snippet to find out how long it takes. So at this point, I'm just taking a snapshot of time before the function call and a snapshot of the time after the function call, and I'm just printing the difference. All right. So let us try to run this. All right. So it is taking about 2 seconds, more than 2 seconds. So let us try to run it a couple of times so that we have average time. So we can see that it takes about more than 2 seconds. So let us try to do the same exercise using list comprehensions. So this is the file which does it. So this is a function. So it has a one-liner code here. So these 3 lines are combined into one single statement using the list comprehension. All right. So this is basically a shortcut for that piece of code. So I'm going to do the same thing here. So let us try to run and see how long this particular technique takes. So if you look at this, it takes about more than 1 second. So let us try to run it a few more times. So it's about just about 1.5 seconds, or just a little more than 1 second. Right. So let's do it for loop again. So it's about, there is about more than a second difference for 10 million elements. It's about half of the time. Okay. So let us see why is this difference coming. And basically the idea is we are trying to append it using we are trying to use a function to append to list. So in order to load this function into the stack, and then unloading it and then again loading it for about 10 million times, so this is where the time is going away. So but here we are not calling the function, and that is where we are saving time. So having said that, so let us try to do it ourselves and look at where is the difference coming from. All right. So let us I'll just remove this code and import a disassembler, a function. This is a module which helps us to disassemble the byte code. So it takes function name. We can pass a function name, and then let us try to print its intermediary code, which is this. So if you look at this particular code, so if you look at this, so this function is converted into bytecode, and we have disassembled that. So it looks like assembly code. So if you look at this call function, this is where we are trying to call this function at line number 1. So it starts executing it from there, and then this is just it just loads the function, and at line number 7 is where we call the function. Okay. So get iter, for iter, store fast, and load fast, these are internal keywords or internal instructions that Python interpreter calls. So this particular thing, so we are calling load method here, so which is nothing but a.append. So this particular line, we can load the method, and then we call the method, and then we have to pop it out. So this is where this particular overhead is coming from. All right, so let us do the same thing for at list comprehension method. Let me take out this test list comprehension. So if you look at this code, so this is much there is no much lesser than what we saw here. So this is basically it's not calling any function here, dot append or anything here. So it helps us to skip that particular statements. So we since we are doing it for about 10 million times, so we save the time to do this. So where did it go? Okay, let me do it, print it again. So this is what we are saving. So this is where this particular list comprehension wins the race in terms of performance. All right, so that is all I had to show, and thank you for watching.